I think it's time. It's 1 p.m. 15 my time, and it's 3 p.m. 15 in Istanbul. Hello, everyone. Super happy to be with you today. Istanbul, as I mentioned in a tweet today, that Istanbul was the last city I visited in 2020 for the good reason. Like I was going to Java Day Istanbul, but got cancelled for a good reason, for the safety of everyone. And I'm super happy to be with you today and be part of Java Day Istanbul as it was planned, even if it's virtual. So I hope you will enjoy the session. And my session today is about containers in Java and the things that you should know and the things that you should avoid before putting a Java application inside the container and deploy it into production. If you have any question, please comment below and I'll try to answer your questions as much as I can. If not, feel free to reach out to me either on Twitter or this is my email, and I'd be happy to discuss anything related to containers, Java, microservices, and everything in between. So I am Mohammed. I work for a DevOps company in Morocco called Xhub, and it's a consultancy company. So my talk today is a live stream from Casablanca, Morocco to Istanbul. Yeah, technology. And my talk today will highlight, My talk today will highlight the story of a Java developer called Ferru. And Ferru is a Java developer who has been working with Java for a couple of years now, and he truly believes in the power and limit of code. He started working with Java, and he kept sharing about this relatively new technology. But there are a lot of people that kind of start onboarding this technology, which is containers. And he wants to start like playing with it, see what limitations it comes with, what new features it offers, and what headaches this new technology brings. So my talk today will highlight first story, starting with the philosophical question: is it a good idea to put a Java application inside a container? We will see afterward how to create effective Java Docker images that are both smaller, faster, and secure. We will discuss some tools and libraries that make working with Java and containers a lot more fun. And we will see the things that we should know and the things that we should avoid before putting a Java application inside the container and deploy it in production. And finally, we will see all the features that has been added to Java to make it more container aware. So as you probably, and as you already know, and you probably hear it in another conference or probably today in this conference, containers are nowadays everywhere. And they are used for a wide range of applications. We'll find them in a huge monolith enterprise application to small serverless application. And that's because containers offers a great number of benefits. So containers offer us easy deployment and easy scaling. So the promise that containers comes with is we no longer need the problem of it works on my machine, but we offer this new standardized way of deployment that offers easy deployment and easy scaling. Containers encourage developers to build distributed systems that adhere to the principle of immutable infrastructure. And with immutable infrastructure, once an artifact is created, it cannot be modified via user data. And immutability extends beyond containers running in your cluster to the way you describe your application in your orchestration, in your container orchestration tools like Kubernetes. So everything in probably in your container orchestration like Kubernetes. So everything in Kubernetes is a declarative configuration that represents the desired state. And it's the job of your orchestration tool to ensure that the actual state of the world match the desired state. So we call that declarative configuration. And it's everything in cloud native nowadays is based on YAML and declarative configurations. One of the big promises also of containers, it offers this efficient resources utilization. We can limit the memory, the CPU, the network that containers can consume. And also containers has a rich ecosystem with many tools and libraries that probably answer anything that you will need. And the backbone technology behind containers, and you probably will you probably know that, but if not, I will just give a quick intro. So backbone technology behind containers are basically two things: namespaces and C groups. So namespaces are basically used for providing different isolated view of the system. So each process will this process can see its own view on different namespaces like process ID, network ID, user ID, and so on. C groups, on the other hand, are used um, to let us implement metering and measuring for the resources that can be used by a process like memory, CPU, block I/O, network I/O, and so on. So in C groups, each subsystem forms a tree structure or a hierarchy of nodes. So subsystem is memory, CPU, network I/O, and so on. So each subsystem form a tree structure or a hierarchy of node, and each process belongs to one node and one node only in each hierarchy. So given a process, it will belong to one node for CPU, one node for memory, one node for block I/O, and one node for network I/O. So initially, when the system boots, especially if you are using Linux as your production system, when the system boot, there is only one node, the root node. And the first processes belongs actually to this node. So even if you are not running containers yet, you are just running one big container with no limitations and no constraints. And then Faro asked himself, is it a good idea actually to use a Java application and deploy it inside a container, especially that the JVM offers by itself a great number of benefits? Okay, so Fatih told me to go a little bit slower. Okay, I'll try. So I'm going slower, I'm going faster because there are a lot of content that I'm trying to cover in this presentation, but I'll try to go much more slower. So then I was saying that Faro started asking himself, is it actually a good idea to deploy a Java application inside a container, especially that the JVM offers by itself a great number of benefits. So the JVM is hardware and OS agnostic, and it's runtime adaptive, which means that the JVM will try to adapt itself and tune itself to ensure the best execution in the target environment. And with that, Faro decided to give it a try. And after reading a couple of tutorials, he came up with this Docker file. So this is not the best Docker file that you can find out there, but he built it, he ran it, and everything is working perfectly. Then Faro asked himself another question. What are the characteristics that my production image and my production container should have to deploy it? And the answer is basically three things. I need my base image to be as small as possible. I need my container to have a fast startup, my container startup. And then, sorry for that. So yeah. So I need a good base image. I need my image to be as small as possible, and I need my container to have a fast startup. And the first thing I mentioned is to have a good base image. And in the context of Java, when we talk about a good base image, we are talking about the JVM itself. And there were a huge discussion lately in the Java community, especially after the new release cadence that we are not familiar with and the new licensing from Oracle. But Java is still free, and there are many providers that are offering Java for free. And if you need support, there are many other providers that are offering that as well. And as Dr. Venkat Subramanian says, there is no such thing as end of life if you have enough money. So if you need support, there are many companies that are offering that. And if you want Java for free, there are many alternatives that you can use. So Java is still free, and that's the thing that you need to keep in mind. The second thing I mentioned that I need from my production image is to be as small as possible. And for that, there are a couple of techniques that we can use from both the Java side and from the container side or the Docker side. Oh, thank you. So in the Java side, thank you, Hussein, for the tip. So for the Java side, there are techniques that are, for the Java side, there is a feature introduced back in Java 9, which is Java Modularity, which allows us to tune the JVM and select only the modules that we need during runtime. It enables us to uh, to to make our own custom GERE as well, putting the JVM in a straight type. So uh, Java Modularity offers basically two things: to select the modules that we need during runtime, and then it could be simple, and possibility to create. It offers also the possibility to create our own custom GERE, which minimize and put your GERE a lot more, and the result will be JVM and a GERE that is a lot more smaller. It contains only the dependencies and the modules that we need, which is a great feature, especially in a containerized world. Sorry for that. Another technique we can use as well is code refactoring, and techniques like code refactoring and code reviews help to detect logic complexity, helps to get rid of to reduce the overall lines of code, and help us to detect if we are using a whole dependency for just a small utility function. So getting rid of those zombie dependencies that are we are not using them, and there are both in the JVM itself and other tools in Maven and Gradle, tools that enables us to detect those dependencies that we are not using during runtime, and they are just sitting there in our jar file, in our war file, or even in our container. So getting rid of those dependencies helps to reduce the size of your image. So that was from the Java side. From the Docker side, the first thing that you need to keep in mind is to use a smaller base image. And generally speaking, the smaller your base image is, the smaller your final image will be. Also, understanding the layers, the concept of layers and caching of Docker and containers help to reduce the final image size. And this means you should probably combine the related comments as much as you can in your Docker file, but of course, don't try to combine unrelated comment just for the sake of producing a tiny image. It's definitely better to break up layers when adding files, but to combine layers when running obviously related comments. Also, cleaning up right away, and it's kind of a general practice while working with Docker, and it's very common to download an archive, extract it, edit the files, or maybe move them in another place, and then forgot to remove the original archive file. So deleting these kinds of file, as well as deleting some files, some temporary log files, some caching directories, and those kind of directories and files can reduce a lot of space in your final image. Also, understanding the build context and using Docker ignore. And depending on your application, you probably want to ignore some kind of directories like the .git directory and the log directory and the temp directory. And one great side effect of using Docker ignore, it helps to speed up the build process, since the files that are sent from the Docker CLI to the Docker daemon are now smaller. And we call that the build context. Also, another feature that was introduced a couple of years back in Docker, which is multi-stage build. And while using Java, you're probably already seen that your image ends up holding a large number of build files that are unnecessary for your application. So multi-stage builds try to offer an elegant solution to this problem by separating the build stage from the production stage, keeping your production image clean without the unnecessary build dependencies. Another important question you need to ask yourself while building your image is whether you want to download the image or download the necessary files during build time, or you can postpone them and get them during runtime. And there is no ultimate question, no ultimate answer to this question. It depends heavily on the context, on what you need, on the startup time of your application. And this is one question that you need to answer at some point. And depending on your answer, it will definitely impact the size of your application. And finally, using some tools like Docker Squatch and Docker Slim helps you reduce the size of your image. And Docker Squatch is a utility function, is a utility that squash multiple image layers in one in order to create an image with fewer and similar layers. Of course, the behavior of the generated image needs to be exactly the same as the first one. And when I mentioned using a smaller base image, one Linux distribution comes to mind, which is Alpine. So Alpine is a very lightweight Linux distribution. Its size is almost 4 megs, and it's based on muscle libc and busybox. So very briefly, busybox combine tiny versions of many common Unix utilities into single executable, and muscle is an implementation of libc as in the standard C library. And this is basically the standardized interface between the user land and the kernel, doing such things like opening file, network connection, and those kind of stuff. But there is a small difference between, actually it's a big difference between Alpine and many other Linux distributions that we are familiar with and we are using today in production. And that is Alpine is based on muscle libc, while others are based on glibc. And that means a C or C++ code that is compiled with glibc will probably not work on muscle, and vice versa. And you may be wondering by now why a Java developer talking in a Java conference mention a C and C++ code. And that's because we as Java developer are using a software, we are using a daily software that has a lot of C and the C++ code in it. And that's basically the Jvm. So in order to ensure a transparent run of the Jvm on Alpine, there are some modification that needs to be made on the Jvm itself. And luckily such project exists, and it's called Project Portola, and you can start contributing to it. It is, and you can start using the early access build. So the project is kind of on pause right now. It has been pushed from Java 13 to Java 14 to Java 15, and it's never made it to production. There are other providers that are offering Java builds based on Portola, but not the OpenJDK. So the project Portola that is part of OpenJDK is not yet made it to the stable release. But you can start playing with it, and we will see a demo in a moment with it. And you will see that many you will find on the internet, and especially on Docker Hub, many images that are based on Alpine. And what these guys are doing, they are not using Project Portola. They are just adding muscle libc or glibc Alpine package on top of Alpine. They are not using Project Portola on any muscle port on the Jvm. And this snippet right here, I took it from the Adobe OpenJDK images that many of us are using in a daily basis. So be aware of that. And as I mentioned previously, the smaller the image is, the smaller your base image is, the smaller the final image will be. And the winner here is clearly OpenJDK 8 JERI image based on Alpine, followed by 2 other images coming from Java 8 and Java 11, and they are coming from Google Cloud Registry. And those images are part of a core project of Google called this rowless container image. And this project aims to create images that contain only your application and its runtime dependencies, restricting what's inside your application to exactly what your application needs to perform its function. So those images are built using Google Bazel tool. They support multiple languages, including Java, of course. And one nice thing about this project is the base image they are using. It's a glibc based image. It's a very lightweight. It's a very tiny. Its size is almost 8 mix, and it can be considered as a nice alternative in the Java context for Alpine. So the base image of this Rolls container image can be used as a nice alternative to, of course, Alpine, since it's, as I mentioned, glibc based. And someone would ask, why should I care? I mean, if it works, it works. And the quick answer is the smaller is better. And the long answer is everything in your container is something that the provenance needs to be tracked and need to be scanned for vulnerabilities. Secondly, each time you are pushing or pulling your container, you are incurring costs, you are incurring expenses in terms of data costs, data transfer costs, and update data costs. And finally, the smaller your image is, the fewer components it contains, the smaller the service attack. And the third thing I want from my production container is to have a small, fast startup. And for that, there are a couple of features that we can use in the Java side, and starting with using the latest version of Java, and especially LTS version and Java 11, because each version it has improved the Java community, improved the startup time of the JVM. So at least you're the Java 11 because it has fastest startup compared to previous LTS version like Java 8 and Java 11. Other techniques exist as well, like class data sharing, ahead of time compilation, and GraalVM. And let's see those actually in action. So I have a small application here, which is basically a small niche application that starts a niche server, and whenever it receives a request, it prints hello world. And my goal here is to measure the startup time of my application. So once the server bootstrap, I exit the application, right? And let me know if you can see the code clearly. If not, I can make the font bigger. So this is my small application. And then I have a benchmarking script here that measure the startup time of my application and measure also the size of my generated image, right? So I have a couple of branches here. So if we do get branch, you can see here that I have multiple branches, and each branch represents a feature either to improve the size of my image or improve the startup time of my image. So the master branch contains a Docker file that is basically simply run our application with Java 13. I call it plain. I call this image plain. It's run my application with no limitation, with no optimization whatsoever. So I'm just running my application with Java 13 with no optimization. So let's start actually by going to CDC, which is Git Checkout CDS, which CDS stands for class data sharing. So to execute a bytecode, the JVM needs to perform a couple of preparatory steps. So given a class name, it looks the class up in a jar, it loads the class, it verifies the bytecodes, and then it puts it into an internal data structure. This takes some time, and of course, it is more noticeable when the JVMs need to run 100 or even thousands of when the JVM needs to load 100 or even thousands of those clause files. But the thing is, as long as the application jar does not change, this class data is always the same. So the JVM needs to execute the same steps and comes to the same results each and every time it runs the application. Here enter class data sharing. And the idea here is to generate this data once, dump it into an archive, and then reuse it in future launches and even share it simultaneously between multiple JVMs and multiple containers. So I have here class data sharing with two versions or two ways. This one, the not commented version, is from Java 13 and onward for latest versions. So the use of class data sharing is heavily optimized and make a lot of easier. We just need to pass this option, which is archive classes at exits, which tells the JVM that I want to save the class data sharing and at this specified file. And then when the JVM it runs the first time, it will save this archive. And then in my production image, I can enable class data sharing, and I only need to specify the JVM where it can find the class data sharing, which will heavily impact the startup time of your application. So notice here, sorry if I didn't mention it earlier, that I'm using multi-stage builds, which this one is my build stage and this one is my production stage. So here I mentioned using CDS from Java 13 and onward. So if you are stuck with versions before Java 13, it was a little bit more complicated. So first, you need to create a list of application classes using the dump loaded classes list. And then we take this the list of the application classes that we generated, and then we pass it to the JVM, and then generate the archive based from this class list. So as you can see, so I generated the list here, and then let me remove that. So I generated the class here, and then took this list and passed it to JVM using the dump loaded class list option, and then I'm telling the JVM here to generate my archive file in this place. Right, so this was CDS, and it really helps to reduce the size of to reduce the startup time of your application. Another technique we can use obviously is ahead of time compilation, and I'm calling it in AUT. So the JVM executes Java bytes code and compiles the frequently executed code into native code, and this operation is called JIT, or just-in-time compilation. So the JVM decides which code to JIT compile based on some profiling information it collects during runtime and during execution. And while this technique enables the JVM to produce highly optimized code and improve peak performance, the JVM does not benefit from this during startup time, since the code is not yet JIT compiled. And here it comes the idea behind ahead of time compilation. And AOT, or ahead of time compilation, actually aims to compile the byte code to native code ahead of time and to reduce what we call the warm-up period. Using ahead of time compilation using GUTC command is a bit complicated. So we need first to generate a file called containing all the methods that have been touched, and for that we need to to pass to the JVM those two options, to log the touched methods and print them, and then it will generate a file like, let me show you. Okay, where is it? We are at EUT, right? Okay, so this is the file. And it will not look like this, but you will need to do some modification to make it look like this. So it contains basically the method that is printed and that you want to compile to natively. And then it contains also two keywords, compile only or exclude. Compile only to compile the methods ahead of time into native code, or exclude to ignore this image. So once you generated this file, you can use it to compile it natively. And you need also to provide the dependencies that you want to include. And using GUTC command, as you will see, is not that, it's not really intuitive, but it could help you in some cases. So using GUTC command, we specify that we want to generate this native binary from the list of methods that we want to compile, and we can specify also the module that we want to compile from the JVM and so on. And then in my production image, I'm telling the JVM here to use the ahead of time shared library, as you can mention it here. So now the JVM will look up if this method has been already compiled, it will load it directly instead of compiling it by itself. It helps to reduce the startup time of your image as well. Another technique we can see is GraalVM. And let me switch to the GraalVM branch. Graal, yep. So GraalVM, I'm sure that there is at least one talk about GraalVM in this conference, if not many. So GraalVM is a research project developed by Oracle Labs and is already in production in many companies, including like Twitter. And it is basically a universal virtual machine written like a universal virtual machine for running multiple applications like in Java, JavaScript, Python, Ruby, and so on. But what excites Java developers about GraalVM is a sub-project called Substrate VM, or SVM basically. And this project compiles Java application to native images ahead of time. So it's also ahead of time application and aims to compile Java application to native image. And the goal here is to reduce the startup time of your application and reduce the so-called warm-up period. So the generated image is no longer a Java application that relies on the JVM, but instead a self-contained binary that contains everything the application needs to perform its function, just like what you will have while using Go or C or C++ code. So using GraalVM is a lot more easier, as you can see. Is pretty much straightforward. You need basically, so I'm using multi-stage build, so I'm installing here native image utility, and using native image utility, I'm compiling my jar file, which is my application, into native image. This will take some time, and in my production image, I'm using Scratch, no base image at all, and I'm copying the native image that was generated from the build stage. I'm copying it to the final stage, so production stage. So this is a huge benefit for the Java developers, especially in container world and serverless world. Self-contained binary, its size is really, really small. So those were some of the features and tips that we can use to reduce the size of our image. How about if we want to reduce the size of our image? To reduce them. So those are the features to reduce the startup time. And now we're going to talk about some features to reduce the startup time of our the size of our application. Sorry. And then we can use, let me check what I can use. It's Modularity. Yep. So the branch is called Modularity, and I'm using here glink, which is a utility to select only the modules. So I'm selecting the modules that my application needs and passing along a couple of options to reduce my custom GRE. So on the build stage, I'm building my custom GRE, and in my production stage, as you can see, I'm using the base image from the source project, and I'm copying and I'm installing the image or the custom GRE I built from the build stage, and I'm running my application using this custom GRE, as you can see here. And we can do the same thing with Alpine using Project Portola. So here I'm using early access of Project Portola. So I'm using Alpine and I'm downloading Java with Alpine, Java for Alpine, which is based on Project Portola, and I'm doing the same thing to generate my custom image, and using the same custom GUI as well to run my application, right? So this is pretty much it. And let's basically go to master. So if I run the benchmarking script, I will have a couple of I will have an output that is similar to, let me show you this one. So in terms of the size, using modularity, either with Alpine or with the source image, helps to reduce the size of your image. So the plain image was almost 350, but using Alpine or modularity reduces the size of our image to only 60 or 50. But using GraalVM really reduces the size of our image to only 13 megs. For the startup time, comparing to the plain image, which took more than 600 milliseconds, if I'm using, we see some slightly better improvements with CDS and the heat of time compilation, and running GraalVM, it's really super fast. So as you can see, it took only 3 milliseconds to start my relatively Java applications. So those were some techniques that you can use both to reduce the size of your image or to improve the startup time of your application. Okay, so as you probably know, containers are nowadays everywhere, and they becomes the executables of the cloud. But our friend Fedor thinks that that containers added somehow a new layer of abstraction, especially for us, the Java developer, since we are already familiar with this standard way of packaging, which is jar file, or which is the Java archive file. And then he was wondering if we can use the same old tools that we are familiar with, like Maven and Gradle, and we already use to generate our Java archive, to generate this new unit of deployment, which is container images. And luckily, such tools exist in both Maven and Gradle. So the easiest way to achieve that in Maven is to invoke a Docker comments using Maven exec plugin. This solution is not so elegant. Another more sophisticated plugin exists, like Spotify Spotify Docker Maven plugin, and this plugin is the embodiment of simplicity. It's basically create your image and to push your image to a registry. And another more robust plugin exists from the Fabric HM Unity, and this plugin does a lot of things. It builds the image. You can start the container, stop the container, create network, create volumes, and a lot of great stuff. If you are a Gradle fan, other plugins exist as well that do more or less the same features and enables you to interact and build your images and push them into your container registry from your Gradle configuration file. Another amazing plugin worth mentioning here is Google Jib, and you probably already heard about it. And Jib is a Maven plugin, is a pure Java plugin available both in Maven and Gradle. Sorry to say it's a Maven plugin, but it's available in both Maven and Gradle, and it enables us to build images without the need of a Docker file, and without even the need of a Docker daemon inside of our machine. And so Jib doesn't use any Docker file, but if it does, the Docker file will look something like this. So since Jib is a Java plugin, it understands our application and put the files that are more likely to change on the bottom and the files that are less likely to change on the top. So it splits our application into multiple layers. It puts the files that are less likely to change on the top, and the files that are more likely to change on the bottom. And this helps to speed up the build process, since if we change in a file, we need only to compile the code file and not to rebuild our application from the beginning. And it also helps to ensure reproducibility. So this was Jib. Another project was mentioned here is BuildKit, and BuildKit is a new project under the Mobi umbrella, which is basically Docker. It's a new project for building and packaging software using containers. And BuildKit introduce a lot of solutions to a lot of problems that we face while using the traditional Docker build command, or the Docker tradition, or the Docker old builder. So BuildKit introduce a concurrent build graph solver, which can run builds in parallel. That's a great thing. So the current Docker builder run commands in sequential order. BuildKit can run them in parallel. Also, BuildKit tracks only the updates made to the files between repeated build invocations, and that obviously optimize the access to the source files. And it comes with a lot of things. But the number one complaint of Java developers while using Docker is there is no easy way to build our application. So whenever we modify one line of code in our application, we need to rebuild the application, run the Maven commands, download all the dependencies from the top, and that creates a lot of problems because there is no volume in the Docker, no volume actually in the Docker build command. So this creates a lot of problem. BuildKit offers an elegant solution to this problem. So actually BuildKit extends the run construction, as you can see here, extends the run instruction to add a mount option as part of the Docker file experimental option. And this is basically, there are a lot of types for the mount option, but there is one particularly that will interest Java developers is the cache type, which we put in a target the file that we want to, or the folder that we want to cache, and then whenever we invoke or launch a new build, instead of launching everything, so BuildKit will see if there is a cache, and then which will load this file to will load this folder and no longer need to download all the dependencies. So the workflow will look basically like this. If you are using BuildKit, the first time you run your build using in your Docker file or in your Docker image, the first time you run your build, it will basically download the whole Maven dependencies, and the second time it will use the cache and load whatever new dependency you have added, and this will speed up obviously the build process, especially for compiled languages. And BuildKit is still an experimental feature, and you need to enable it. You need to have Docker 1809 or latest, and you need to you need to enable it. It's an opt-in feature, and thus you need to enable it. Oops, sorry. Another important topic here is image versioning. And there are a couple of techniques that you can combine to version your images, and nothing can stop you from combining those images. Another thing to keep in mind is to avoid using latest, especially if you are using some orchestration tool like Kubernetes, as it's stated clearly in the Kubernetes documentation. Why? Because it is not, for three simple reasons. It is not dynamic, and that means if you push a new image with a tag which is neither empty or latest will not be created, obviously. It is also not descriptive, and that means like operations like deploying a new version or rolling back to another version is not possible if you don't have distinctly two separate versions. And finally, it is easily overwritten, since it is the default value, which makes it vulnerable to human errors. Another important topic here is security. And this basically needs a session on its own, but my goal here is to give you just some bullet points to keep in mind while working with containers. Starting with, you need to ensure that everything running on your containers does not, especially if you are using third-party containers, you need to make sure that those images does not download anything during runtime. Also, think of running some security analysis tool and vulnerability scanning tools for your code before putting it in your image to prevent a malicious user to attacking and found malicious script and malicious and inject malicious code in your code. Also, for Docker images, there are a lot of tools and a bunch of tools that you can use to scan your images and detect if there are some security issues. Also, using image sign-in and Docker Content Trust. And once enabled, I mean, I'm talking about Docker Content Trust. Once enabled, Docker daemon will sign your image using the publisher private key, and then when a later user wants to pull the image, the Docker daemon will automatically verify this image for authenticity and integrity using the publisher public key. Another important principle to adhere to is least privilege, and the least privilege is a well-known principle in security. But in the context of containers, it means that each process and container should be run with the minimum set of access rights and resources that it needs to perform its function. And the main benefit of this approach is even if one container is compromised, the attacker should still be very limited in being able to perform actions that provide access or exploit a vulnerability. A couple of practices can be followed to achieve that, starting from making sure that the processes inside your containers that does not run as root. So exploiting a vulnerability that does present exploiting a vulnerability does not give the attacker a root access. Also, running your file system as read-only so that attackers cannot override data or save malicious scripts, and also limiting the resources that can be used by a process can help to prevent some kind of attacks like those attacks. And also, as mentioned previously, running a minimal container OS helps to reduce service attack. And also having monitoring tools in place should to alert if in case of a malicious behavior, and also having auditing tools in place help to compare images and see what this changes, if I can say. Another important practice in software engineering is testing, and it is really hard to achieve this real isolated real-world isolated testing environment. So containers help it to make this process easier. And one project worth mentioning here is test containers. One of the maintainers of test containers was here before me at Java Day Istanbul, which is Kevin. Gave a nice talk about blockchain. But test containers is an amazing library that use containers to build, to enable you do some integration testing. So it supports multiple Jvm testing frameworks. It provides lightweight, throwaway instances of many common databases, and it provides a couple of nice features. And the main thing, the user experience or the developer experience is really awesome, and it's really easy to work with. So with that, our friend Farouk seems happy and want to try using containers and deploy it kind of into production. So I'm starting to run out of time, and I'm going to demo a quick demo really quickly. So here I'm going to run Spring Boot application. Oops, okay, I don't know why my keyboard is really slow. Done. Come on, done, okay. And let's, yeah. So this is basically a Spring Boot application, the Pit Clinic application. And as you can see here, I'm running it. I'm tuning the Jvm to print, let me make the font bigger. I'm tuning the Jvm to print the options that it starts with. And as you can see here, the Jvm starts with almost 2 gigs of the heap size. This is part of what we call the Jvm Ergonomics, which is the Jvm try to ensure the best performance in the execution environment. And by default, the Jvm, if no options were passed, it will select 1/4 of the available memory as the maximum heap size. And if you can see here, you can see that I'm allowing I'm using Docker for Mac, and I'm allowing it to use up to 8 gigs, almost 8 gigs. Let me make it bigger. As you can see, it's almost 8 megs, and 1/4 of the 8 megs is 2 megs as 2 gigs, as you can see here. So the application started, and okay, so if I open the application, oops, not that one. If I open the application, come on, okay, let me open it. If I open the application, you can see here that it's a simple pet clinic application, nothing fancy about it, right? So let me go to my console and then exit the application. And one nice thing about using containers, as I mentioned previously, is it enables us to specify the limit and memory consumptions and those resources utilization, right? So let me, let's run the application with 250 megs of memory. So quick pull, as you can see here, even if it's specified that the application can use only 250 megs, it still use up to 2 gigs of memory, which is weird, even if I specified that it can use only 250 megs. And if everything works as expected in the demo, the application should actually fail to start. Yep. Okay. Oops, it started. Why is that? Docker run. Weirdo. This is so weird. It actually should fail to start. Oops. Okay, so yeah, let me give it another try and see. Let me call it B and see if the application actually started. So the thing I want to see here is, even if I mention it that the application should use only 250 megs. So I'm using Docker, and using the M option specifies the maximum allowed memory that my application can use. And the JVM still thinks it can use up to 2 gigs of memory. But as you can see here, the application now failed to start. And if I use Docker inspect, but this one, because we switched it to B, you should see that here it received an out of memory kill signal, as you can see here. And it received it, why? Because it used more memory than it allowed to use. So it received an out. So the Docker daemon was watching the container, and the container used more than 250 megs of memory that's specified, and then it received the Docker daemon killed the application. And if you are using Kubernetes or some orchestration tools, you will see your container restarting and restarting and restarting without any meaningful message in the logs. So we are Java developers, and when we have memory issues, right? What we do, we add more memory. So let's add actually mod memory, and let's make it this time 500. Okay. Let's make it name, and yep. So this time, actually, if the demo works as expected, the application will manage to start. And this will not happen if you have a lot of a server with bigger memory. But if you want to have a look about how the JVM manages its memory internally, we can use a nice tool, which is Gcmd. So Gcmd is an internal tool of the JVM, available in the JDK. It sends diagnostic requests to JVM about many things. So I'm sending here the JVM request about the memory, and I'm telling it to format the numbers to megabytes. And as you can see, the JVM uses actually more than 500 megabytes that are specified, and it's almost using 800 megabytes. And that's because my application is actually swapping. The application is using actually swap, and we can prove this by using memory, okay, dash memory. So there is an option in Docker, memory swap, that to disable swap, we need to put the same value as the memory. So our application will not be using swap. And notice here that the JVM is completely unaware of the constraint that I put to my application. So the application is starting, and as you can see, it managed to start somehow, but it didn't manage to survive. And it received an out of memory kill signal, as you can see here. So it received, let me make it bigger. It received a kill signal, and that's because the application used more memory than it allowed it to use. And for the record, for the application, I was using Java 8 build number 121. And I will be back to it in a moment. So that was an epic failure for my friend Fero, and he wanted to understand why this is happening. And the first part of the question is history. So the containerization movement started back in 2000 with FreeBSD jails and Modularity zones, and then with C group and namespaces appeared in 2006 and 2008. The containerization movement gained a lot of attention, and then when Docker appeared in 2013, the containerization movement exploded in popularity. However, Java was here since 1997. And when Docker first appeared in 2013, Java 7 was already out and the work on Java 8 already started, which explains somehow why the JVM is not container aware. Another part of the question is Jvm Ergonomics, as I mentioned previously. So the Jvm Ergonomics, it's some assumptions that the JVM makes based on some information it collects from the underlying host, like memory, the number of CPU, and many other things. And it sets default values for your application to ensure the best execution on the target environment. However, if the JVM fails to get the correct values or get them from the wrong place, this nice feature turns out to be a nightmare. And that's exactly what happened in the case of our friend Fero with the memory. But the same thing would happen with the CPU as well. And this will impact the some internal JVM stuff. It will impact some popular Java APIs like the Stream API and the Fork Join API. And it will impact some popular Java frameworks like Elasticsearch, Tomcat, Java tools, sorry, like Elasticsearch, Tomcat, and a lot of tools. And as I mentioned, I was using Java 8 build number update 121. And if you are using the same version of Java or before, so there is no way that to make the JVM container aware. And you need to specify the startup options to JVM to make it lower than to not reach the container constraints. And or you can use same of the hack that used by the Fabric 8 community. So what they did, they get the constraint from the C groups, and then calculate the correct values for the JVM, and then pass the values as actual values and calculate them, and pass those as startup options to the JVM. In Java 9, so the issue is known. In Java 9, we started to see some improvements with the introduction of some options for the memory configuration and some options for the CPU. But for most of them were experimental options, and good luck convincing your manager to use experimental option in production. In Java 10, we saw more fine-grained control, more fine-grained options that allows more control over the memory that can be used by a process. We also introduced a new formula to calculate the number of CPUs, and we introduced an option to calculate the total number of CPUs, or to specify the number of processes that the JVM can use. In Java 11, the Java community continued to make the JVM more container aware by removing the experimental option that were introduced in Java 9, and the introduction of container metrics and new options that fix a bug or an underutilization issue that appears with Kubernetes. In Java 12 and Java 13, the focus was to make the Java flight recorder more container aware. In Java 14 and Java 15, the focus was to introduce new functions like the support for V2 and C groups, and the Java community continue its work to make the JVM more and more container aware. So final words, it's never a good idea to put your application in production without monitoring tools in place. So those are some tools from both the Java side and Docker side that gives you an insight about how your JVM is doing and how your container is performing. Final words. Is it a good idea to put a Java application inside the container? Yes, definitely. It comes with a lot of benefits. Use the latest version of Java, as it has a lot of improvements compared to other versions, or at least use the latest LTS version. Keep in mind that Java has a rich ecosystem with many tools and libraries that make working with Java and containers a lot more easier. And finally, there are many tools that help you to make your container journey with Java a lot more fun. So with that, I want to thank you. I'll be here for a couple. I know I'm very out of time for more than 15 minutes, and there are other amazing sessions that are out there. So if you want to ask me any question, I see here for a couple of minutes. If not, please enjoy your conference. And if you have any other question, either reach out to me on Twitter. My Twitter handle is Laytoon, or send me an email. So I see here if you have any question for 1-2 minutes, and then I'll basically leave. Thank you, everyone. So there is one question from Hussein. In the recent past, the future of Docker has been discussed, but we told today JVM tuning and other issues. What is the latest on this? Will Docker continue to live? So we need to separate between two things: so the Docker, the company, and the Docker, the technology. So my belief is containers, and that's what I mean by the Docker, the technology. So containers will still here and will continue to live with us for a very long time. And that's because they unleashed great things, and they unleashed a potential, and there is a real business that is building upon containers ecosystem. Now we have Kubernetes, we have Istio, we have a lot of companies that support those things. We have security analysis. So there is a real ecosystem and a real business around containers. So containers and or the Docker that technology, or the technology that Docker the company made popular, will be with us for a very long time. So Docker the company, things are a bit complicated for them. I have some friends there. They are doing good. They switched the vision, and they are now more focused on the developer productivity and developer tools. Will Docker the company be with us for a very long time? I can't answer this one. But yeah, if your question was about the technology, so be sure the technology will be with us for a very long time. I hope I answered your question, Hussein. Selim, what's your personal stack for build plugins and base images? So I'm using a lot of Jib for older version of Spring Boot. I'm using a lot of Spring Boot applications, to be honest, so I'm using Jib. Now, the latest version of Spring Boot include a default way kind of to build your image, which is using I forgot the name, build packs. So now Spring Boot are using build packs. So there is another alternative that you can use to build your images directly from Spring Boot, which is build packs. I'm exploring those as well. So my stack is I'm using Jib to build my Java images, and using this release base image for my production if it's on our platform, and then if it's for a client, we comply to the Java license or the Java the Java version that he wants to use, and if it has license of March on a lot of questions. So I'm using a lot of Jib, and I'm using Scaffold, and I really recommend to have a look at it. It's if you are using Kubernetes, it will help you a lot to build your application and see changes instantly. So I'm using Java. I'm using Jib to build my images. GraalVM, I'm experimenting it. Still, a lot of clients as well, and a lot of customers are experiencing it, but I have never seen, at least in my my network, which is relatively small and only based in Morocco, any application that uses the GraalVM native image in production. A lot of my clients, small of my clients, start exploring GraalVM as the JVMs, as its other great benefits, but not the GraalVM, the native image. I hope I answered your question, Hussein. If not, please clarify more. Thanks, Siri. Okay, so no more question. Thank you, everyone. I hope you enjoyed the talk. And if you have any remark, even of my talk, I know. Yeah. So that's why I was going super fast, because I have a lot of things that I wanted to share with you, but the time was very limited. So the repo for my talk is available here. You can go to it and check it. It contains all the things that I mentioned here. The talks will be or the slides are freely available. And as I mentioned, if you have any question, want to discuss anything related to microservices, cloud native Java applications, I'd be more than happy to do that. Thank you, Java Days Istanbul. Thank you to the organizers. I didn't have the chance to say this in the beginning, but thank you, everyone. They are doing a great job, and enjoy the conference. Bye-bye, everyone.